All right, let's take a look at this. Looks promising. Let's see what's in here. Too many words. Way too much math. Nope. Nope. Bingo. That's what I need. All right, so I've got my stock material chucked up in the lathe here, and get ready and give this a go. Actually, you know, you guys don't need to see all the boring lathe cut parts here, so I'll just skip ahead to the finished product. All right, that looks about right. Here's a fun idea. Next time you're at a party and, you know, all the snooty people are asking you questions like, who's your favorite author, or what do you like to read? Just look at them and say, you know, anything by Kurt Schreckling, and just see if they admit that they have no idea who that is. Or even Forrest Mims. You know, I can't get enough of Forrest Mims. This is actually a very good read. Even if you have no desire to build your own engine, this is just a great book. You know, it gives you, the first half of the book tells you how the engines work. It gives you all the formulas needed if you wanted to design your own. And then the last half of the book tells you how to build it with all the measured diagrams, plans for everything here. So definitely a good book here. Now, obviously this engine is not going to be very efficient. It does work. People have made them and they've put them on airplanes and they've flown airplanes with them, and it is a good little engine, but you know, the compressor is plywood. The turbine blades you're bending and grinding to shape yourself, so don't expect it to be the most efficient engine out there. On the plus side, I think I spent all of about, I don't know, $10 to build this, because I was able to get metal materials pretty much for free scrap from where I work. And the only thing I really had to buy were the bearings. On the other hand of that, if you buy a commercially made engine, you're going to spend a few $1,000s. Now, when I made this, I really had no intention on putting it on anything. I just wanted to build it to see if I could. So let's just kind of go through a teardown of it. This isn't going to be a build tutorial, just to show you a few parts of it, just in case you do decide to build one of these on your own. The first part here, the intake cover. Now, this is held on. I shouldn't have pulled it off yet. This is held on with 3 nuts here. I've removed these just for, you know, an easy video here. And then you would tape over that seam with a thin strip of aluminum tape. The cover here is made up of several pieces of aluminum. 2 of them are spun. If you're not familiar with spinning aluminum, your best bet is to find somebody who is, where you're going to spend a lot of time experimenting and practicing to get this to work. There's a lot of videos on YouTube about how to do it, but it's kind of a lost art. But anyway, there's the cover. Next thing we'll pop off here is the Tel Cone. I modified the Tel Cone from the instructions in the book. They had you put little clips and springs to clip it in place. I just tack welded on this hose clamp here, so I can just slip it on, tighten up the hose clamp, and I'm done. So I like that quite a bit better than the method they did. Inside here, again, we said the compressor is plywood. Again, it's not screwed in, but that would screw into the shaft. Here you can see the end of the shaft, and the first bearing is right in there. The compressor, made up of 2 end plates of plywood. The black is carbon fiber wrapped around. Have a steel insert here where the shaft to go in, an aluminum center cone here, and all the blades are thin plywood. Again, it works, but it's not going to be as efficient as a commercially bought engine. It actually uses, you know, something more like what you'd see out of a turbocharger from a car. This was my 4th attempt at making this compressor. I did not have a rotary table, so I kind of did all that by hand. If you have a rotary table, that would definitely be a lot easier cutting these slots to put the vanes in. Next part will pop out of here. Just push there, pop out the shaft, maybe. There you go. And this is the main shaft, and I have the turbine wheel attached to it. This is the back bearing right in here. Again, that's just a circle of stainless steel, chrome nickel moly stainless. Cut, twist, grind the airfoil shape with a Dremel tool. And the book tells you how to balance it. Obviously, balance can be an issue. So the book tells you how to balance the turbine wheel and the compressor. Shaft is just aluminum with steel inserts on each end. The compressor guide vanes, let me see if I can push this out here. There we go. This part here, this is the shaft for the, or the tube for the shaft to go through. The number 1 bearing, again, is trapped in here between the aluminum plate and the steel piece here. This tube is for oil delivery. This one actually uses a separate oil tank. I know the commercially bought engines now, the fuel is an oil mix, and so you don't have a separate oil tank on a lot of them. This one's kind of falling apart. Some of these vanes are loose. Again, it's just a plywood ring glued around here. If I ever revisit this and remake this, I'll try to just machine the whole thing out of aluminum here. That's what most of them are now. But, I mean, it works, but as you can see, I have a few repairs in it. And the combustion chamber in here. The combustion chamber, it's stainless steel, thin stainless steel. This tube right here is for propane. That just goes straight through and out. With this type of an engine, you have to first get it preheated with propane before you can then start running it off of kerosene or jet fuel, which on this engine, I never made the line for the kerosene yet. I built it, put it together, ran it on propane. I was thrilled. It worked, so I just kind of put it in a box, and that was it. One of these days, maybe, if I get back into the mood to work with turbine engines, maybe I'll make the line so I can run it off of actual kerosene. But until then, no. This is just 3 pieces of stainless, rolled, drilled, cut, welded together. The book gives you the patterns for all of this. And then finally, the main case here. Now, the book called for using a camping propane bottle. I could not find one with the right dimensions, so I just got a piece of steel, rolled it, welded to seam, and then beat the ends over around. And this all gets welded up and installed. Yeah, lighting there's not too good. It's a little dirty inside, and as you can see, I don't know if you can see inside of there or not. Yeah, not really. But a friend of mine said he can get me some ceramic material, and he thought it'd be cool if I coated all of this with ceramic material. And the first time I lit this engine off, that all just burned away. So either it wasn't ceramic, or I didn't follow the instructions, and maybe I was supposed to put it in a kiln and bake the ceramic on first, or whatever. But the white paint is high-temp muffler paint. And the first time I ran it, yeah, it got a little bit too hot. And this whole end was just on fire, glowing red. This was just glowing bright red. Probably overheated it. If I do run it again, I will replace this bearing. And I also need to install the temperature probe. I have not done that yet. And I also need to install an RPM sensor, just a little tack sensor in here. You paint a white stripe on here, you put a tack sensor looking at that, and you can read the RPM off of it. I just didn't do any of that. I connected the propane, I sprayed compressed air into the front, lit a match in the back, and away it went. And it actually worked very well. And I'm not going to do a run of this on this video. Like I said, if I ever decide to re-entertain this project, I will make the line for the kerosene. I'll put the temp sensor in it, the tachometer in it, and I'll run it properly. But again, this is just something I wanted to get out there, show you guys the parts and pieces for the Kurt Schreckling model turbine engine. And that's it for now. So thanks for watching.